Okay, welcome to the final session of Racketcon. Neil, do you have the video?
I'm setting it up right now.
What we're going to be doing in this final session is running a tutorial on typed Racket, which people have alluded to, shown some programs in, but not really talked about how to write programs in. If you want to follow along, many of the pieces of code that we're going to be writing are already written and available in this GitHub repository. But mostly to follow along, you just need to go to the Racket webpage. And we're going to be looking at programs that you maybe have already seen, have already run, that are written in Racket, that are come from the documentation, the tutorials, and the webpage for Racket. So that's how we're going to structure this tutorial. Let's start with this first program. Finds Racket sources in all the subdirectories of wherever it is that I saved this. So we get a whole bunch of Racket files. That's Racket. What happens if we wanted to use typed Racket to write this same program? That, ladies and gentlemen, is 90% of the point of typed Racket. All we have to do is take our program that was written in Racket, add typed / at the front of our # line, and our program type checks. That's what it's telling you, because you can tell that because it's not telling you that you did it wrong and giving you large and frightening error messages. Of course, if we wanted large and frightening error messages, we could do this wrong. We could say something like, well, what if we tried to pass in, I don't know, 17? Uh-oh, there's an error. Highlights this call to regex match. The typed Racket knows that 17 wasn't the right argument to regex match. And if we ran it, we would get a larger error message that tells you about all of the different ways that Matthew has made it possible to use regex match, none of which are with 17 as the second argument. So let's go back to our correct version. And there we are. All of our Racket files running in typed Racket. That's the big idea of typed Racket. We take Racket programs, we slap a label on them saying we want to type check these programs, and with little or no change, they do. And that's the goal that we've oriented the development of typed Racket around. However, it doesn't always work with literally 0 other changes to your source file, so we're going to see some more examples of that. So let's look at some of the other little programs that come with the Racket webpage. How about this little echo server? So this doesn't return back to us because it's running an echo server on port 12345. And we can stop this if we get bored. Now what's going to happen if I try to write this in typed Racket? Unfortunately, it's not going to be perfect. Well, what does our error message say? Actually gives what I think of as a very accurate error message. It says, I don't really know what's going on here, so I'd like some help. type checker is pleading with you not to just leave it sitting there in the dark with no information. We're going to have to help it out. We're going to have to tell it what the type of echo server is. And what is the type of echo server? Well, it's a function, right? And it's a loop. You saw lots of loops like this. And how many arguments does it take? Zero. Zero arguments. And what does it return?
It doesn't return.
That's a trick question because it doesn't return. So now we're going to tell it what the type of echo server is by using one of the forms that TypeRacket provides to us to program, to add types to our programs. So we're going to switch to using the let : form, and we're going to say that echo server returns, well, somebody suggested void, but we could also pick some other options. How about string? That works. How about... The wonderful thing about infinite loops is that they return all of the colors of the rainbow. We'll stick with void, though. And you can see that in the background, Dr. Racket isn't just expanding your program, it's also type checking your program and telling you that, well, now we have sufficient type information to type check. And now we can sit in a typed infinite loop waiting for communication on port 12345. So now that's the second most significant idea in TypeRacket. One, we add typed to our language, and then the program type checks our whole module. Second, usually the type checker can't figure absolutely everything out all by itself. We're working on that, but there's only so many hours in the day. So we ask you, the programmer, to give us some help. And the type checker prefers to receive help in the form of type annotations.
Is it possible to make it always know what to type it, or is there some holding problem? You will always have to have
The type inference problem for all of TypeRacket is definitely undecidable, if that's what you're asking.
Why can't it assume a default of void if you don't specify anything?
It could assume a default of void, but if that's our experience with a variety of typed languages, is that if it assumes some default, such as void, which is not my favorite programming result, but it might be yours, that if it assumes a default, that you're going to end up getting bizarre type error messages that don't correspond to the program you thought you wrote. So TypeRacket doesn't make assumptions like that in most cases. Now let's continue with our little investigation of these little programs.
I have a question about the last one, actually. Is there another way to do it besides the let :
Sure. Well, let loop is a convenient way to write one-off loops. But if we wanted to do this in a more reusable way, perhaps, we could write an echo server function that looked more like this. And then when we wanted to run forever, we'd invoke echo server. And it says we need to give it a type for echo server. And to do that, we can annotate our function, our definition, in one of two ways. We can write something very similar to what we wrote before. Now it works. Or we can separate out this type declaration from the function and write it like this. And this works as well.
Can't you use that style of declaration with let loop, or those?
That style of declaration wouldn't make sense with let loop because that loop binding isn't available at the top level. One should annotate one's identifiers at the level that they're declared, and that's hard to get to in let loop. So now we have a slightly refactored version of our function, and we now see a different way of writing down the types of type bracket functions. Okay. With that, I want to take a step back from porting our little examples and talk about sort of basic features of type bracket that you need in day-to-day programming. Well, there's a few things. First, you might want to take advantage of your regular Racket features. Define and lambda, structures and macros and functions and numbers and input ports and all of the good stuff that you already have in Racket. Those are all already available in type Racket. And the second thing that you're going to want to do is you're going to want to decorate things that you already have with types to inform the type checker of what you have. And that uses forms like the ones we've already seen. You can say just to make Danny happy, we can define x to be 42 and tell type bracket that that's an integer. We also can make a similar definition. We can also annotate structure definitions. If we wanted to describe pairs of integers, let's go with some symmetrical naming. We've now seen annotated structures, and we can write programs that manipulate same kinds of Racket data that we already have in our regular Racket programs, exactly the way we would if we wanted to use match to write this program. It works just as well. We're able to port all of the things we know and love from Racket over to typed Racket with the addition of these type annotations. Of course, not everything is already comes with support for types. So sometimes we have to specify that we need the typed version of something. So one thing that I'm clearly missing from this function is some test cases. So let's write some test cases. And this is going to be well, this is why we write test cases, because clearly I don't know how to compute the distance from the origin. But this is really...
3, 4, 5.
This is easier when you construct your test cases so that they work out easily. And what do you know? Everything works. So what's different here? What's different is that instead of just being able to use rack unit off the shelf, libraries that don't start with Racket, you need to write typed / in front of them, or for some libraries, there's no typed version at all, and we'll see how to handle that in a little bit. Yeah?
Suppose you write only a typed version of a module. Is there an untyped version that's automatically derived for users of untyped Racket?
Yes. So the short answer is you don't even need an untyped version to be derived because the typed version automatically works with the rest of your program. Let's, well, why don't we use this program as an example. Let's provide X and Y. We've taken our typed program. I didn't have to change it at all aside from making sure we provided the data we wanted to make available. And here's a program that knows nothing about types at all. And it's able to use X and Y just the same as if that was written in any other language that we wrote in Racket. And that holds not just for loading into regular Racket, but for loading into Scratchy, the language that Matthew created this morning. If you wanted to write some portion of your Scratchy runtime library in typed Racket, or use some typed functions that Neil wrote in the math library to make your Scratchy sprites go in very precise directions, then at very high speed, then that'll work just fine.
Perhaps this is getting ahead of things, but if you export distance from there and then try violating the contract outside.
Well, that sounds like an example I should try. Okay, so that surprises me greatly.
Oh, you can even provide hair stuff.
I Turns out this is Matthew's fault. No. So one of the interesting things about typed Racket, or at least interesting for me, it's potentially less interesting for everyone else, except when they run into it, is that typed Racket is a complicated use of many of the techniques that Matthew described this morning. And therefore, sometimes it tickles some of the less frequently tickled corners of the Racket implementation, and you just saw it tickling one of those corners with respect to submodules. So the lesson here is that tests make your program not work, commenting them out makes your program work. Right, Matthias?
I won't say it is in public.
I thought I just did.
Google Hangout.
Okay. But Prabhakar wanted me to do something incorrect with distance. How about 7 and 12? Well, distance only takes one argument, so we'll stick with 7. So it says distance expected a pair, and we give it 7. And
Does that happen at runtime, or does that happen?
yes, this happens at runtime. This is a contract violation, the same as if you violate any of the other contracts that people have written down as Racket programs. So you can see that this is a runtime violation because if I this works just fine. In fact, we could see that just by the fact that our background expansion has already finished and hasn't raised any syntax errors.
And if this were being written in typed Racket, it would still be a runtime? Or would be good. Okay.
The lesson here is that typed Racket automatically figures out whether it should be type checking your file and whether it should be looking back at the other file that you're requiring to figure out if there were any type definitions in there that it needs to be aware of, so that it prevents you from doing bad things like this. Okay. So far, so good. Now let's switch context back to taking advantage, back to having a look at the Racket examples. Let's look at a little bit of a more interesting example. Pretty pictures always make for good examples. And this has been one of my favorite pretty pictures to make with computers for a long time. Well, here we have the Sierpinski triangle in a nice red color. And what happens if we want to put this into typed Racket? Well, we're going to have to do something about this toHTTP image require line. So the rule that I said previously was that you don't have to change require lines if they start with Racket. And this one doesn't. So we're going to have to do something different. As it turns out, there's no automatically typed version of the 2HTTP image library. But fortunately, we can write our own. We can do exactly what the maintainers of 2HTTP image would do if they wanted to provide a typed interface to it. We can describe what the typed interface should be. Well, and if we're going to do that, we're going to need to start with the documentation. So up here we have all of the functions in the 2HTTP image documentation. And fun as it might be, I don't think we're going to spend the rest of the tutorial looking at every single one of them, but let's consider the ones that we need for this program. So, well, there's triangle, there's above, and there's beside, and there's freeze. Okay. So we need to figure out triangle, above, beside, and freeze. So who can guess the types of these various functions just from their uses here? What's the type of triangle? So it takes a complex, a string, and the symbol red. Okay.
Arrow triangle.
And it produces a triangle. Okay. Okay, how about above? Well, above is going to take the result of calling a triangle. So probably it takes a triangle as an input. And, well, it takes another argument. What, Matthias, what do you think the second argument is? Probably another triangle, right?
Two triangles.
Two triangles.
Two triangles. Okay.
No. Two space triangles.
Two of triangle. Oh, yeah.
Side takes a triangle and another triangle and produces a two triangle. Freeze takes a triangle and
Returns an icicle.
okay. So there's one problem here that I see. So does anybody else see a problem here?
What's an icicle?
Yeah, Matthias got one of these types wrong here. We're gonna remember this about him. He got the type wrong. This is actually supposed to be string union symbol.
I put that in so he knows it. Yeah.
And this gives me a great opportunity to talk about another fun feature of Typed Racket, which is union types. Typed Racket supports union types. You can see that they're called union types because they're written with a big U. Definitely the causality went in that direction. So union types say that you can provide either a symbol, as we do here, or a string, as Matthias clearly would prefer you to do, to the triangle function. And what are we going to do with, if we had a union type, how might we make use of it? Well, let's think about that. So imagine that we had some piece of data that was either a string or a symbol. And we wanted to figure out how many characters were in it. So this is going to produce a number. And now, Matthias, how many con clauses am I going to need here?
I always want to be like a student. I don't know.
Okay. So we have either a string or a symbol. So we're going to have to check which one of these we had, because Asumu's efforts to the contrary, very few Racket functions operate automatically on both strings and symbols. And then we're going to do, otherwise we have a symbol. So far, so good. So what have we learned is the first step to making your program a typed Racket program. We're going to change the hash lang line. And then we're going to need to annotate this function. And remarkably, that's all we have to do. Typed Racket, surprisingly enough, knew exactly what it needed to do to handle this function exactly the way we would have written it in Racket. And the way that it does this is by using the things that it knows about the string function, the string question mark function, to figure out that over here, that when we use SS, it's going to sometimes refer to a string and sometimes refer to a symbol. And this is one of the ways that typed Racket is designed to let you just change the hash lang line, add a few annotations, and get a typed version of your original Racket program, rather than having to change a bunch of things around. Okay. So now let's go back to our Sierpinski triangle. And so now we need to figure out how to specify that the 2HTTP image library provides all of these functions at the types we want. So let's see. What we're going to do is we're going to say that we need the require typed form, which is a special version of require that lets us express exactly these kinds of specifications. Now there's only one problem here, which is that what's a triangle? We're going to need to define what a triangle is. Now, who in this system is defining triangles? It's not us. It's not us writing this Sierpinski function.
It's Robbie.
We shall not name the creator of the triangle function, but suffice it to say that the library that we're trying to import already knows what it means by triangle, even though it may have found other names to call it, like image. And it's going to tell us what triangle means. And so we're going to have to respect that. And what that means is we're going to have to tell the type system about these types that come from other libraries. Fortunately, we can do that. We say there's some opaque type that we don't know about that comes from another library. It's called triangle. And it's associated with some predicate. some function that determines whether or not you're really a triangle. And because Robbie didn't realize that triangle was the type he was describing, he decided to call this function image. Okay. So far, so good. So now we can construct triangles. Ta-da! Triangles. What if I wanted a blue triangle?
Well,
Tragically, I'm out of luck.
how about a triangle of the square root of -1 solid red?
We'll get to you in a second. This demonstrates another interesting feature of typed Racket. It's again designed to work with the way we program in Racket, which is that tick red is a funny kind of type if you're coming from pedestrian type languages like Agda or something. Which is that it tells you that there's exactly this symbol out of the whole space of symbols, and only this one is allowed. This blue symbol, we're not going to have any of that. There will be no blue triangles in this program. And we can say, actually, that we want either red or gray, because we're sad Red Sox fans. And now we can construct a gray triangle or a red triangle. Still no blue triangles, though. And it knows that blue's not allowed before it even tries to compute that triangle, because I'm sure that the 2HTTP image library is just going to blow up when asked to construct a blue triangle. Okay. Well, now let's move on to the rest of these functions that we need to manage. But I'm going to abbreviate that with symbol. So now we need the beside function, the above function, and it takes a triangle and a 2 triangle and produces a triangle. Okay. Now, turns out that because of its exploiting efficiencies in the representation, the 2HTTP image library actually represents 2 triangles and triangles using the same data structure and exposes that fact to its clients. We're going to be having a serious talk with the author of this library at a later date. But that means that I just need to tell typed Racket that 2 triangle is really the same as triangle. And not only that, icicles are just triangles too. And now we get back to our very familiar insufficient type information error message, which tells us what about our program? That we need to add some more type annotations. It even said please. When was the last time you saw a type checker that said please? It's still learning. It wouldn't want.
Does the type checker ever apologize?
No.
The tech apologizes.
And here we go. And I like to think that it's just a little bit prettier as a picture because it's created with typed code. And of course, if we had picked slightly different types, we could have made this program a little bit shorter without these extraneous defined types. But the lesson here is that we can respect the abstractions created by other libraries, specify that we're going to respect those abstractions, define them to the type checker in terms of predicates, and then program against arbitrary abstractions created by untyped libraries without needing the type checker to suddenly understand deep facts about how it is that freeze works by compacting the representation. You have a question?
Yeah, I was thinking about what would happen if you added different opaques for the random other abstract types we talked about, like two triangle and freeze. So icicle, you'd end up with this, if you set opaque, icicle image count, right?
Mm-hmm.
So either you'll end up with sort of a union of icicles and triangles, and the type checker will not like it as a function that you might have a union of them, or image hunt is enough for type Racket to figure out that they're the same thing. So I'm curious.
The answer is that you'll end up with a union and it won't type check.
Okay.
Because type Racket treats separate predicates as separate. It doesn't unify them. So if you have...
So I can have like two different colors of numbers. I can have one number hunt that's a certain type and another number hunt.
you could do that.
That's all.
It'll be hard to work with because you'll have to manually import the entire and give types to the entire numeric library at both of those types and then define some interoperation semantics between your blue numbers and your red numbers, but whatever floats your boat.
Yeah. I have a lot of time on Saturday sometimes.
Now that you've crowdsourced the rest of your work.
You might want that for units, right?
Yeah.
Yes.
Very good idea. One is common and one is degrees.
Okay. So that leaves us with a nice pretty little triangle. So now let's step back and have a look, continue looking at our examples. Kind of a fan of this program. So what should I Google?
I'd like it.
This demonstrates that Google is indeed doing a pretty good job finding things on the internet. It finds the guide to typed Racket first.
This is what stress you don't parse HTML.
I think this is a lesson in the success you can have parsing HTML with Regex. Now, all this information about how to use typed Racket. The Wikipedia article, many fun things about typed racket can be learned by attempting to parse this HTML with a series of regular expressions. What if we wanted to parse it with, make those parsing regular expressions typed? Well, we're going to need typed versions of our net libraries, and we're going to need to annotate. Let me Google that for you. We don't really care what it produces. Well, it produces a list of strings. Or a list of bytes, rather. Now we can learn about typed racket from typed racket. Maybe not the best way, maybe not the best implementation of online documentation, but it'll do for now. Yeah.
Can I come further return type in this case?
You need to specify it. It could, in this case, infer the return type because, let me Google that for you, isn't recursive. It would probably take a while if it kept going back to Google on every recursive call. However, typed racket doesn't make the distinction between top-level definitions that are and aren't recursive, and so it expects you to provide annotations for all your top-level functions. Yeah.
Can you call it type, can you require a type module from a type module?
Yeah, so we saw that earlier, but let's, what?
Why is there a separate module for the URL?
So that's because the type net URI codec, for example, module, is taking the existing net URI codec library, which doesn't have any types in it, knows nothing about typed racket, and it's adding a type wrapper that specifies the types of the various functions.
Right, but why couldn't you just add types to the net URI codec?
Certainly we could.
He did, in this library.
Oh, I think the question is why not just change the implementation to use typed racket?
Oh,
This is certainly a
If there's no opening.
this is certainly a viable option. However,
we're looking for volunteers.
if you patch is accepted, but the point is that writing this typed wrapper is a lot less work than going back and figuring out exactly what it is that the author of net URI codec was thinking when they wrote the horrible and convoluted code that's there. I actually have no idea what the quality of the code in that file is like, but we would have to go back, figure out what the types we wanted to specify are, and do that for the entire internal implementation. Whereas this file just specifies the interface. We can have a look at it, in fact. And you'll see that it's really just this much code. Handles a very small number of functions. We don't have to learn anything about URI encoding in order to write this.
But couldn't you just put this declaration into the net URI codec?
No, you can't. You can't have both typed and the typed declaration in the untyped file. We type modules on a module by module basis, so therefore you have the typed version. So you know that you have to specify typed / in front of it to get the typed version.
But you could give this the shorter name and give the untyped from the library.
Yes, we could change the names of untyped programs to be please don't use me because I might have type errors in this file /
Yeah.
Matthew, what do you think about that?
Untyped is enough.
So here's our typed little web scraper. Now this example will give me an opportunity to demonstrate another important aspect of dealing with existing libraries in typed Racket. There's really two kinds of problems that you face when writing typed programs in typed Racket. One is writing programs. Turns out that sometimes that requires thinking hard about what you're doing and sitting down and scratching your head and debugging, figuring out what the representation of stuff is supposed to be. And typed Racket will help you with that by providing type error messages, but you still have to do some programming. The other part that's different is you have to figure out how to interoperate with existing libraries that might not have convenient type specifications. And we've seen some of that with require typed. And command line is an example of another issue along the same lines. What if we wanted typed Racket version of this? Now, command line, there's no command line : form, sadly. Maybe there should be. But nice thing about typed Racket is when there isn't that form, we can use the building blocks of those forms to do the work ourselves. So we just need to specify the types for dice and sides. And it turns out we can do that even though we don't know anything about how the command line macro works. Say dice is a string, and sides is also a string. Okay. So, bunch of errors, but now we're able to get somewhere because we've told it that when the command line function hands you values, they're strings. Turns out that the problem here is you can see just in the part that my cursor is on in the error message, which is that somehow we ended up with complex numbers and also false. But really, there shouldn't be any falses in this program, right?
Oh, no. If you put a non-number in your command line, you'll get false out of string to number.
Brilliant. Come collect your winnings after the lecture. String to number turns out to have an error reporting mechanism that was designed before the design of error reporting mechanisms. And therefore, when you hand it a string that doesn't map nicely to a number, Racket has made the wise choice to map those to false. There are other choices that other programming languages have made in other contexts. Sadly, Mike has left, so he can't tell us about that. But let's just say that false is among the less bad choices here. The solution is to just say, well, if this turns out to be false, I just want to blow up. This program is not going to work because you didn't do the right thing. Now, we can use a convenient form provided by typed Racket called assert that says, you better provide me a non-false value. Okay, so that tells us that we don't get false, but we do get a large number of other possible numbers. And our types for the in-range function expect real numbers. Now, turns out Racket has complex numbers. String to number can return them. So we're going to assert not just that this isn't false, but that this is a real number. And we're similarly going to assert that that what we get here is an exact integer. And now our program type checks. Why did I pick exact integer? Because, well, if you have a die with 3.2 sides, you're probably not going to have a very fun game. Although you should call me and show me the die, because that'd probably be pretty cool. So now we can save this program. And how many dice should I roll? 42. And how many sides should they have? 20. So this is the result of your dice roll. The first one was an 8, the second one was a 6, the third one was a 6, the fourth one was a 3, the fifth one was a 17. I think you get the idea.
The 5, 3.2.
That's translate.
Indeed, it did. Okay.
Can you do better message than that, though?
No, actually, it's impossible to do it better. Oh, there's another lesson here, which is that one more thing that you often need to do when you're converting your program from Racket to typed Racket, you need to deal with more unexpected cases than you did in your original program. One of the things that's nice about untyped programming languages is that you can just ignore some of the behavior of your program, and as long as you never run into it, probably your program will continue working. However, type checkers require you to consider all of the behavior of your program, including those when you want to roll 3.2 dice, or die with negative 17 sides. What would that do? Anybody have any good suggestions for generalizations of dice rolling to negative numbers?
How about just a natural number?
Sadly, natural number is really long to spell in Racket.
What happens when you run it?
So, it turns out that the random number generation, well, let's make this a little bigger. That's bigger, right? So expected an integer in 1 to 429. Well, actually, integer in 429, 4967087. And turns out negative 17 isn't one of those. Oh, here's yet another lesson about typed Racket, which is that It does not prevent all possible errors in your program. It would be tricky, but pretty cool if it did, but it doesn't. So one of the errors it doesn't prevent in your program is you passing negative integers to the random function. And the reason it doesn't is that it would be often kind of a pain to prove to the type system that you were sure this input wasn't a negative integer. But it does expect certain basic levels of sanity. It's not going to let you provide strings to the random function, even strings that might look sort of like numbers. But we have defined rules for what is allowed and what isn't allowed, and we can see those by looking at the type of random. That's a little more than I thought I was going to get. So, turns out that there's some interesting different things that we can do with the random function. So, if you call it with one pseudo-random number generator, then it produces a float. If you call it with an integer and a pseudo-random number generator, then it produces a natural number. If you call it with an integer, it produces a natural number. If you call it with no arguments, it produces a float. And it says there's maybe even more stuff that I can learn about this procedure using print type. Right. Turned out, actually, there wasn't any more that I could learn about it. Oh well. But now I have learned sufficient. So we can explore the restrictions and non-restrictions the typed racket puts on us, and sometimes there's more information there than we might expect. Okay. Now I want to get to one more interesting example. Does that keep happening? Oh, that's from the web page. Honestly, this is one of the coolest features of Racket, I think. It comes with a plotting library that's so easy to use that it fits in 2 lines of code. Now here's a plot of the cosine function in blue and the third derivative of the sine function in red. But what if we want to write this in typed racket? Well, we're going to need to do something about plot. Turns out there's no pre-existing typed version of plot, so we're going to have to write our own. We've got the function. Well, let's see, what does a function return? Returns a 2D renderer. Inconveniently, 2D renderer is provided by plot utils, so we'll have to require that as well. Okay. Function is going to produce one of these. And, well, it's going to take some other arguments. It's going to take some sort of function type. It's going to take some numbers, let's say real numbers. Those are the bounds of the plot. It takes a color specified with the color keyword, but the color keyword appears to be optional.
Just blue.
Ah, just blue, okay. Blue is feeling left out, so it wants to have this function all to itself. And what kind of functions are we plotting? We're going to plot real valued functions. And now we just need plot, which takes in a list of R2 D2s and produces, well, what does it produce? It produces an image, but we don't really care about what it produces. Uh-oh. Well, we forgot something important here. We forgot to provide annotations on the deriv and thrice function. So let's start with deriv. Well, deriv clearly consumes a function and produces something that consumes a function, or consumes a real number and produces a real number. Oh. Okay. Still not happy about thrice, though. Well, thrice is actually a lot like deriv, right? Oh, that's unfortunate. Actually, we're tripling the derivative function. So now I'm going to have to say that the input to thrice is that whole type up there. And I really hate typing that much. So I would really prefer it if I could not have to type that much. So I could define a type that's real to real to real to real and use that in multiple places. But that's sort of selling thrice short. Thrice is actually a pretty cool function in that there's no numbers. It'll work for any f you give it. As long as f can be composed with itself, thrice is fine. So actually, thrice works for any, or for all, a's, takes an a to a function, and produces one of those as well. And now we get the happiest message in any Racket programmer's life: background expansion finished. Or at least any typed Racket programmers. And here we have our pretty pictures again. So what's going on here is polymorphism. We can abstract over the argument type to f in thrice and write this for whatever we want. And not only that, but typed Racket automatically figures out how to use thrice for the complicated type of deriv here. Okay. Turns out that no, you can't pass thrice to thrice all by itself. We get an error saying that can't figure out what the arguments are. And in general, typed Racket won't figure it out when you try to apply polymorphic functions to other polymorphic functions. It requires you to help it out. So how are we going to help it out? We're going to help it out by telling it what A should be for one of these thrices. So for this one, we're going to use this form for instantiating thrice to be a real-to-real function. And now our program type checks again.
If the non-derivative
Derivative is not
take a
nice.
while.
Numerically, it's going to take a while.
Yeah?
Is this an inference issue, or is it values don't have polymorphic types issue?
This is an inference issue.
So I could, on the first thread, say that it's a for all alpha with alpha or alpha 2 for all alpha or alpha or alpha.
Yes. Although I'm... yes, and I think that would probably... yeah, that ought to type check as well. So, however, this ninth derivative thing is kind of bugging me. Fortunately, I have an expert on the plot function here. Can I make it sample fewer points?
Yeah.
How do I do that? I think probably you should tell me to read the documentation. But instead,
That's what I was going to do just now.
instead I'm going to take the lazy way out and produce worse approximations.
Will that help?
Oh.
No, that's not. That'll produce worse approximations, but not in a way that's helpful.
It's a parameter called line samples. Or you could use a keyword to the function renderer. The keyword's called samples.
Change it to do only twice.
And it takes.
An integer.
And
Give it 2 just to see equivalently. That's impressive.
I feel cheated.
Change the price twice.
Just take it. Here's what it's called.
And if that doesn't work, take another effort.
There you go.
Oh, 2 samples, it's beautiful.
Okay, let's increase the number of samples. Now that'll only take 10 times as long. And that's a weird looking function because it's sampled.
Yeah.
So now we're taking the fourth derivative. So we're able to quite easily add new functionality to the little wrapper that we created around the plot library, and really just took this one extra little bit of specification. And even when we wanted to use complicated features of the type system, we only had to help the type checker out a little bit more. I actually want to try one more thing. Uh-oh. Turns out that when you write your contracts wrong, your program doesn't work.
Two sets of files.
You've saw two files.
Ah, yes. I blame you for this, Neil. Okay. Well, suffice it to say, you can write your specifications for the behavior of other libraries in such a way that the other libraries do not behave that way, and then it turns out that your program doesn't work. However, your program doesn't work in a different way than it might have if you just naively wrote a program based on some assumptions about how the library worked. Instead, what you get is a program that halts as soon as it can tell that there was a disagreement about what was going on across this interface. So we have fail stop as soon as there's any kind of confusion, instead of computing on for a while and then getting the wrong plot of the sine curve, which we really wouldn't want. Okay. So that's enough plotting. Back to racketeering. Sadly, there's no typed data log. Are there type systems for data log?
Yes, there's a type system for full log, and I was thinking about to do a data log. You might even be able to predict better what polynomial classes are.
That would be fascinating.
That's a little
How does type racket interact with macros in general?
so.
So, one of the wonderful things about Racket is that you've been seeing that the entire time, because it's very hard to write Racket programs without using macros. So let's take this program, for example. Now, how many macros are there here? That depends how you count, doesn't it? But I count 1, 2, and then 3, 4, 5, 6, 7, 8, 9, 10 macros in this program. You can't see most of them because they're hidden in the invisible space between the left parenthesis and the operator.
If we get to the ones wrong.
Oh yes, there's actually another one here, and then there's another one there. Yeah, so there's two more that I forgot to count. So there's a lot of macros in this program, but the ones you're probably thinking of are ones like for and command line. Oh, actually, in range is a macro too, so that's another one. But Typed Racket transparently handled the fact that command line and for are macros.
Are you asking the question where you can define syntax?
Right.
Oh.
Ah, well.
Count the number of open grids.
So, can we say define syntax? Well, let's say let's make this into assert integer. So now we can use this and we still aren't providing it with command line arguments, but we wrote this macro just fine and we can use it in our program. Typed Racket handles those macros that you write for yourself the same way it handles macros that other people have written for you, like command line.
You provide command line arguments about the right open the preference in the language.
Yes.
So what?
So you can use macros the same way you would in regular Racket. Now, how it deals with macros is actually an important part of what we did with dice and sides here, because command line is a macro that creates new binding forms. We saw a lot of those in Matthew's tutorial this morning, and that means that we are going to need to annotate those newly bound variables with types. But command line doesn't come with any place to write types down. So Typed Racket lets you smuggle types into the syntax of arbitrary macros using abbreviations that start with hash open curly. And that way, even though command line doesn't know anything about Typed Racket at all, and Typed Racket doesn't know anything about command line, you can say the things that you need to describe about your variables in this program without any trouble and without needing to rewrite the implementation of the command line.
Except for the hash.
I've gotten to like the hash. I write it in all the keywords. We write it on the beginning of every program. It's a friendly, rackety character.
You've got a text over the hash.
Maybe this is too deep, but are those annotations actually on the identifiers?
Yes.
And so you could maybe lose them in a certain macro accidentally? Or, you know, if they run something more different than what they did. I don't know, maybe that never happened.
So the point of these annotations is to put them on identifiers so that when other macros move those identifiers around and eventually place them in appropriate positions to be bound to, say, the command line arguments of this program, they're going to still have the information that we wrote down right here saying that they're strings. And then Typed Racket is going to get those out of the resulting program and say, oh, hey, you wrote down that this was a string. Now I know what's going on here.
So I think that there is actually a case where they can disappear.
Properties, so a bad not property association.
Well, so if you wrote a macro that expanded into that command line thing here, exported the macro and then used the macro in another file?
I think that works. That'll get that turns into a quote syntax which serializes correctly.
But if command line were a macro that dispatches on a different pattern that might recognize in string here, then it might throw a string and string.
Yes, so if your macro ignores its input in or transforms its
But
input.
it has ambiguous patterns for types that haven't matched the type.
No, it's at read time.
Also, as far as
Yes.
What's the invert type of lambda e bang bang e?
So I think the question you're asking is, this is really like the program defines syntax, bang bang syntax, and then we're going to do syntax parse stx and we're going to get an e, and then we're going to expand into so we're going to need to so your question might be, wait, why did that work? I didn't think that would work. And the answer is that typed racket is about the runtime behavior of your program. And the way it handles macros is by looking only at their results. So if it doesn't attempt to distinguish between programs you've written with bang bang and programs that you've written using the scratchy language and programs that you've written in plain Racket. And similarly, it doesn't attempt to look at the way that your program got to be the way it is. In particular, it doesn't look at the parts of your code that only run when you're compiling. Typed Racket's whole goal is that when you've compiled your program, we've already ruled out some problems, like adding strings together. But that means it's free to ignore other problems that might have already happened when it's running, like type errors that happen at compile time when you're executing your macro. So the short answer is you don't have to write down types for your macros. Types for macros is a hard research problem that many of good friends of mine have worked on, and Typed Racket is not attempting to tackle that. Does that answer your question?
Well, all the special forms have types, right? Well,
no.
So the special forms have types in the same way that bang bang has types. So we don't try to look at how bang bang works. What we do is we look at the program that results from running bang bang. Similarly, we don't try to look at how match works. We look at the program that results from running the match macro, and that produces a big Racket program in a simpler language. We just look at that simpler language.
FAM's Typed Racket checks the kernel language that we expand into. Those forms have types, nothing else.
Does that make sense?
yeah.
Okay. We're coming up to the end of the allotted time for this tutorial. So I just want to say that available on the GitHub page for this tutorial is our files for all of the programs on the web page, on the main Racket web page that are written in Racket, so not the data log and beginning student programs converted to Typed Racket. And it turns out that every single one of them converts as easily as the ones I've shown you. So you have to do things like write down type annotations. Sometimes you have to change the require line to a typed version. Sometimes you have to use require typed to write your own wrapper for a particular library that doesn't have a typed version. And sometimes you have to add some additional error handling where the original author of that program couldn't fit error handling into 7 lines and 40 columns. But that's all you have to do. And turns out that that's all you have to do for lots bigger programs as well. So you can go and look at, if you look in the Racket documentation, you'll see this tutorial on systems programming in Racket. Which actually shows off a bunch of my favorite features of Racket in the runtime that haven't been talked about much at all today. But turns out that all of that works just as easily in Typed Racket. And you can also find on the GitHub page for this tutorial fully worked programs for every single one of the steps of code for this tutorial. And they go through exactly as easily as the 7-line programs that come on the Racket webpage. So you can follow along with Matthew as he builds a continuation-based web server with memory limits and servlets. And you can do all of that in Typed Racket using exactly the tools that I've shown you here today. So,
can you explain in 3 sentences why the Big Bang program does not convert many of those people who are thinking macro and Typed Racket as a class?
So I think the program Matthias is referring to is one of the ones that's not converted here, which is that
the simplest program of all.
Not convinced that this is the simplest program here. This is a simple program that manages an interactive game. Let's play this. Let's play our game. However, it turns out to be quite difficult to add types to this program. And that's because the Big Bang program, the Big Bang macro that you see here, has a bunch of very complicated pieces of runtime infrastructure that appear when you look under the hood of how it's implemented. And adding types to those is much trickier than adding types to the libraries that we've seen so far that mostly just provided simple APIs. So, and it turns out that we'd need additional infrastructure in the type system that we don't have to manage the expansion of Big Bang. So some macros turn out not to work as straightforwardly as the ones that I've shown you. So macros that build a whole new kind of specification language. Macros like Scratchy, for example, which expands into a bunch of uses of the class system, and it turns out the class system then expands into a bunch of uses of the structure system. But we have a big abstraction that's hiding us from the types that the underlying Racket system sees. When you have that, you need the type system to do some more work. And in some cases, the type system does do that work. We can handle some uses of the class system, for example. But for arbitrary, new, complicated abstractions, like Big Bang, the type system is going to need some help. Fortunately, most of the time, when you're trying to write Racket programs, you're going to be using the built-in Racket abstractions, like you are when you're writing the web server in the more tutorial. And those abstractions work straightforwardly with typed Racket. If, however, you're using the unit system or universe with Big Bang, then life becomes more difficult. Ryan?
So I wonder actually if it's possible to minimize the expansion of Big Bang to something that's more amenable to typing. But also,
See me after class about that.
yeah, you have typed regions in untyped modules, is that right?
Yes.
Do you have untyped regions in typed modules?
No.
Because that seems like it would provide a solution to the Big Bang issue.
Oh, yeah.
I think that I believe that would be potentially more complicated, but to provide, but it's a possibility. Carl?
So I'll tell you, I'll guarantee you can take that new program and get it to work with little work on type Racket, Big Bang type Racket, because that program, my contribution to the front page, and I adapted it from a program that I verified in ACL2. If they can handle it, you can handle it. With what?
Real heroes, not empty heroes.
Yeah.
So,
I mean, I think for any finite number of things, Sam can handle those things.
But I did it with Big Bang in general. It's like-
What of them handle the last thing now?
there was one more question.
Can you type information from within a macro?
No, you can't. Type information comes after we've run the macro. This is a fundamental aspect of how typed Racket works. The reason that we're able to let you use arbitrary macros, like the bang bang macro that we wrote, is because type checking comes after all of those are gone. And having an interplay between those is something that we're looking into for the future, but it's not something that's in typed Racket. Okay, so I think I'm going to stop there. We've had an excellent day. I've enjoyed this tutorial. I hope you've enjoyed typed Racket, and even more so, I hope you've all enjoyed Racketcon. So thank you.